Hi everyone, putting together this video to follow up on the last lecture that we had, the lecture involving phase changes of matter. And in the lab, in class, I used water as a demonstration. We started with ice water, and continued to heat the ice water until it melted and increased in temperature and then began boiling. In that process, we saw this happen. We started with ice water, let's say somewhere around there, ice water to the point where it all melted, and then the liquid water heated up, okay, and increased to a point, the boiling point, which is 100 degrees Celsius. So the melting point was, 0 degrees Celsius, okay, and the boiling point was 100 degrees Celsius. All right, and then we saw the water boil for a while, and the important point to this was that we saw that during a phase change, there was no temperature change, and that is a very, very important observation to make. We would have predicted that, that the temperature would just keep rising the whole way as we were adding heat, okay? But we didn't see that happen. In fact, we saw the temperature level off and not change during the phase change. So while we saw melting happen, so this was melting, okay, there was no temperature change during melting. During boiling, there was no temperature change while that material was boiling, okay? When it was just liquid, we could add heat and the temperature did change, okay? Now, we could calculate the amount of heat that went in by Q equals MCAT, okay? So we could know the mass of the water, we know the specific heat of the water, and we see a temperature change in the water. The temperature change is from 0 to 100 degrees Celsius, okay? But during melting and boiling, there was no temperature change. So how are we going to measure a change in heat? How are we going to measure the amount of heat that goes in to the system if we can't measure the temperature change? Because there is no temperature change. Then we're going to do this. We're going to use heat of vaporization and heat of fusion. Okay, heat of vaporization is the heat involved in boiling, and the heat of fusion is the heat involved in melting. Okay, and we have values for that. Okay, so here are the values for the change in enthalpy. You can notice here that we need a number of moles in order to calculate the amount of energy that would go into boiling water. If we know how many moles of water we have, we can calculate how much heat would be required. If we knew the number of moles of water we had, we could see how much heat it would be required to melt that water, that solid water. Okay? In class, then, we tried, I think, a couple of pretty easy problems, which I'm going to skip now. Okay, these are pretty easy to calculate. I will post the notes in the student resource folder, but I would really like to move on to a more challenging problem now. Okay, and I think that's on the next page. All right. So Here, we're going to use, yes, we're going to use these values now to solve these problems. We're going to start with letter A here, okay? And I will just talk you through this. In fact, this is where we left off in class when the bell rang for fourth period. All right, so when we're working through problems like this, it's always smart to draw. Okay, so I've drawn a graph here, and in this problem, we're taking 26 grams of water at 30 degrees Celsius, okay? So we're starting with liquid water at 30 degrees Celsius. 30 degrees Celsius would be like the temperature of a really hot room, okay? So water at 30 degrees Celsius, and we're going to turn it into all steam at 108 degrees Celsius. Okay, now if I run through this heating curve, we're going to add heat to this water until it reaches the boiling point. Okay? Okay, this is all liquid until we get to the boiling point at 100 degrees Celsius. Okay? And then once we reach the boiling point, we saw in the lab, when we demonstrated, you can add all the heat you want, but you're not going to change the temperature. Okay? All of that heat energy is going into a phase change now. It is not changing the temperature. It's not changing the kinetic energy of the particles. It's basically separating those particles so that you're going from a liquid to a gas. All right? So during this time, we're going from liquid to gas. And then once we've reached all gas, that's all gas, then the temperature increases again until we get to 108 degrees Celsius. Okay? All right, so in this problem, we have 3 stages. Each one of those stages requires a separate calculation. All right, so we're going to start with number 1. Okay, now there is a change in temperature here, so we can use Q equals mc delta T. Okay, so here I'm going to solve for number 1. Q equals mc delta T. Q equals mc delta T. All right, the amount of energy, that's 26 grams of water, 4.184 joules per gram degrees Celsius, and the change in temperature is 70 degrees, okay? Going from 30 degrees Celsius to 100 degrees Celsius, that is taking us up that curve, okay? So that is 70 degrees Celsius. Let's see if I can write that in there, 70 degrees Celsius, okay? I'm going to calculate that now. All right, running that calculation, I get 7,614.9 joules. Great, wonderful. Now, second part. All right, what about this phase change where there is no temperature change? Well, what I'm going to use now, because I know that what's happening there is I'm boiling, we're going to use the heat of vaporization, 40.7 kilojoules per mole. What do we need first? Well, we need to know how many moles that is. Okay, so that's 1.44 moles of water. You should know how to calculate that. 1.44 moles times the heat of vaporization, 40.7 kilojoules per mole. 40.7 kilojoules per mole. Remember how I always stress units. Okay, by the way, that would calculate the change in the enthalpy. So 1.44 times 40.7. All right, that is 58.8 58.8 kilojoules. All right, great. Part 3. Okay, in part 3, guys, we've got a change in temperature again. All right. Now, this is a change in temperature of steam. We're going from 100 Celsius to 108 Celsius. Okay. And I want you to focus on the specific heat. The specific heat of steam, 2.05 joules per gram degree Celsius. Okay, I'm going to write that in. Okay, so the specific heat for steam is 2.05. We have 26 grams of steam. The steam changed temperature by 8 degrees. It went from 100 to 108. Okay, the rest is just calculating. All right, and that is the calculation. Now, in order to find the change in enthalpy for the whole thing, the entire change in enthalpy is going from start to finish. All right, and I wrote that in red. Now, I want you to really focus here, okay? Remember how I keep telling everybody about units. All right, now, we got kilojoules, we got joules, we got joules. We're going to be adding all of this together. Why don't we convert everything to kilojoules? So this is going to be 7.6 kilojoules. There it's 58.8 kilojoules. And here, this is 0.426 kilojoules. So adding all of that together to get a delta H, that is going to give us a total of, so that gives us a grand total of 66.8 kilojoules, okay? So, again, my advice, always draw out the phase change curve, okay? So that you can see where temperature changes are, where phase changes are, and everything, okay? All right, I'll leave this video to you now. I'll leave the rest to you and work through the problems in the homework. I think I'll make another video showing me working through maybe one of the homework problems. Or actually, I'll tell you what, I'm going to make a video doing B on this worksheet. Okay? Thank you.